Okay, so the nice thing, your equations are correct. Here, though, instead of using a p, usually we use the p to represent profit or something we want to maximize. This problem's asking you to minimize cost, so typically we just use a c, but nothing wrong. You could use a p, it's fine. Just so it fits in, so you kind of understand what they're doing in the book. As far as your equations, they're both correct. Your constraint equations, perfect. Objective equation, perfect. Oh, yeah, I see why you can't use a c. We're good because you use c as your variable. So anyway, long story short, who cares? Let's go through this problem. The thing that I question is, why did you choose to graph it by going slope-intercept form? That seems really, really hard. I mean, look at these fractions. Ugh. And I'm wondering if that's where you went a little awry. So yes, the goal here is we just want to sketch. But I would recommend, why not, whoops, excuse me, go back to here. Why not just go just using the intercept method of graphing? And if you don't remember this from your previous courses, here's a brief review. Just find the x and y intercept of each equation. So the first one would be found by putting in 0 for c, and then the second intercept would be found by putting in 0 for m. It's a really effective method for solving this type of this type of problem, because we know we're staying in the first quadrant. So you're just looking for where are your intercepts, and this gives it to you. So let me fill those in. Okay, so do note, I wrote these in alphabetical order. So this variable is c, then the next one is m. So essentially, when I substitute in 0 for c, I'm left with 80m is greater than or equal to 40. So 80m is greater than or equal to 40, but we don't, 140, but we really don't care about the greater or equal then. Just think of it as equal to. And then, so we solve by dividing by 80, divide by 80, so that gives us m equals 1.75. So that's what we fill in right up there. I hope that makes sense. So then vice versa for the other one. I just say when m is equal to 0, solve for c. So now I have an x and y intercept to graph this equation. So now I just quickly sketch my graph like you do. Make sure you do sound effects whenever you graph. It makes it way more fun. Okay, so now I'm going to plug in 0, 1.75. So maybe somewhere right about there. And then I'm going to do 2.30. So 2.30, connect the dots. Now, one thing you will notice that, well, you won't notice it because you're not with me in class, but what I always do when I do something like this, man, my pen didn't want to do that. What I always do is I label it. I would call this equation A, this equation B, because if you start to get more equations, it helps you keep track. So now there's equation A, graphed by the intercepts. Now we do equation B the exact same way. So down here, I'll do it in red. We're going to say what happens when I plug in 0 for C, what do I get for M? Vice versa, when I plug in, 0 for M, what do I get for C? And we get these values here. They're rounded, but that's fine. So now for graphing equation B, we have 0, 1.5. Notice that is lower than the other one. So I just have to make sure my point goes lower than it. The other one is 2.9, which is further out. So it's going to go over there because it's comparing to 2.3. So now when I draw my graph, you will notice I have a wonderful little intersection here. So now, for my shaded regions, I use test points to see where I'm going to shade. So very quickly, 0, 0 is always the easiest for equation A. 0, 0, so that'd be this whole part would become 0, this whole part would become 0. So is 0 plus 0 greater than or equal to 140? That is false. So I don't shade down here, I shade on the other side. We have our real world constraints, so we're shading here. And whatnot, it would keep going. Checking the other one, 0, 0. So again, 0, 0, 32. Greater than or equal to 32, that's false. So we're shading above on the red as well, so it's going to continue. So essentially, this is our shaded region. So now the question is where are our corner points? Where are we looking? Well, following the shaded region, we essentially know it's this part right up here, right? So, whoops, undo. Bring me back. Let's try, well, we'll just ignore it. Whatever. We're going to come along here. We know we have one corner point right there. We have another corner point where the two lines intersect. A third corner point right there. So those are the ones we need to test. So those points are the 0, 1.75, 2.90, and then the intersection, just pop that in a matrix and have it solve it for you, and I'll give you the